Okay, so we talked last class about these atoms and kind of the history of the atoms and how today we kind of agree that the protons and neutrons are located in the nucleus. These both add to the mass of the atom. The protons have a positive one charge. The neutrons have no charge. The electrons are then found orbiting about the nucleus. I would say in these predicted paths, not necessarily perfect little orbits. And the electrons have a -1 charge. So we can kind of visualize like we have this tiny little nucleus, this tiny, tiny massive center, and we have these negatively charged electrons flying around that nucleus. We then have two simple little formulas that I think we can always refer to here, that mass number is going to equal protons plus neutrons, and the charge of the atom, which can then cause it to become an ion, is going to equal the protons minus the electrons. So let's go through some practice problems here. So number one, what is the atomic number for iron? Well, the atomic number is going to be this number right here. And that will always hold true for a given atom. So we can look at iron. The atomic number is 26. That also means that it's going to have 26 protons, which is the question 2 here. So atomic number is the number of protons. Okay, down to 3 now. What is the mass number for an oxygen atom with 7 neutrons? So if we look at the periodic table again, it looks like oxygen is always going to have 8 protons here. Now it looks like the mass number of oxygen is usually around 16, but we got to look back at the problem here, knowing that it always has 8 protons. So 8 protons plus 7 neutrons would mean that this time the oxygen is going to have a mass number of 15. So I guess this means that they don't always have the same mass number. Question 4, what is the average atomic mass for copper? So on Earth, we have all these different forms of these atoms. So we can have different types of copper, really. And the periodic table shows us the average atomic mass, the average mass of all these isotopes. So the reason we have a decimal place here on the periodic table, the one we're used to looking at, is this because it's an average of all these isotopes. So sometimes copper might have a mass of 63, and sometimes it might have a mass of 64. I guess this right here, the 63.55, this is the average of all those isotopes. So I'm just going to go to the hundredths place, 63.55. Maybe grams per mole, but we'll just leave it at that. What is the mass number for strontium-88? That's what that 88 right there means. So when you see a number after the name of the element, that number always refers to the mass number of that element. Okay, what is the symbol now for an atom with 9 protons and 10 neutrons? So I would start out right here, 9 protons. We look at our periodic table. 9 protons is going to be fluorine. It's always fluorine. And then if we want to know the mass number, I would say 9 plus 10 equals 19. So we could say it's fluorine 19. Maybe another way to write this, then we could also write this, where we could put the mass number on top and the atomic number on the bottom. Okay, let's look down below now. How are the atom pools similar and different? So we have hydrogen 1, we have hydrogen 2, and we have hydrogen 3. So I would say the thing that's the same is that they all have the same number of protons, and they actually all have the same number of electrons. Now, how are they really different here? This first isotope of hydrogen only has, well, actually 0 neutrons. This one has 1 neutron, and this one has 2 neutrons. So the thing that would be different would be the number of neutrons, which would then affect mass number. Okay, over here on the right, how many protons are in the following atoms? Looking at these mass numbers, it's kind of irrelevant. Protons is always the same for a given atom. So oxygen 16, oxygen's element 8, it has 8. Iron 56, 56 irrelevant. Iron always has 26 protons. Sodium 23, 23 is irrelevant. Sodium always has 11 protons. Sodium 22, 22 irrelevant. Irrelevant. It always has 11 protons. Okay, now the second set of problem, how many neutrons are in the following atoms? Now we got to take into account the mass number, and we got to think about that formula that mass equals protons plus neutrons. So I would say that neutrons would equal mass number minus those protons. So oxygen 16, well, we said above oxygen has 8 protons, so 16 minus 8 would mean it has 8 neutrons. Iron 56, we said above that iron always has 26 protons, so 56 minus 20, so we get 30 neutrons. Sodium 23, sodium 23 always has 11 protons. 23 minus 11 would be 12 neutrons. Sodium 22, 11 protons still, so 22 minus 11 is 11. Okay, last problem here. Using a Bohr model. So we need to think back to the class where we discussed those models of the atom. And I would say the Bohr model of the atom had the protons and neutrons in the nucleus, and then described these energy levels, these orbits, not yet orbitals, but orbits where the electrons are orbiting around the nucleus. So draw a Bohr model of the atom for a neutral carbon atom with 6 neutrons. So let's get the 3 values down. So carbon is right here, element 6. That means it's always going to have 6 protons. Now the fact that it said it's neutral means that the charge would be 0. So that means protons and electrons will be the same. So it's going to have 6 electrons. And then it tells us it has 6 neutrons. So I would get 6 positives, 6 little neutrons. I would start drawing energy levels. Now we also mentioned, we don't need to memorize this really till later, but the first energy level is going to have a max of 2 electrons. And then after that, we're going to start getting into the numbers later. So I'd go 1, 2, 3, 4, 5, 6. Okay, hope this helps.